Let's consider this problem. A firefighter has two pumps available for draining a flooded basement. One pump can do the job in 4.0 hours, whereas the other pump would require only 3.0 hours. If both pumps are used, how long does it take to drain the basement? So if one pump can do the job in 4 hours and the other's in 3 hours, working together, it seems like they would take less than 7 hours. It would actually seem like they should take less than 3 hours, because if the one pump can do the job completely in just 3 hours, that means that if it has any help, it should go even faster. So our answer is going to be less than 3. So let's think this through, how we can set this up, because we can't just add the numbers together. We can't just average 3 and 4 because we'd end up with 3.5. So let's talk about rates. The rate of the first pump, it can drain the basement in 4 hours. And so I can think of this as the rate of the first pump being one basement drained in 4 hours. I will circle back around to use significant figures here. That means the rate of the second pump could do the job in 1/3 hours. So that means in a given hour, one can pump 1/3 of the basement and the other can pump 1/4 of the basement. Another way to think about this is that if we want 1 over the total number of basements, so 1 over T, that would equal how fast the first pump can go and how fast the second pump can go. In other words, 1 over the total time equals 1 over the time it takes the first pump plus 1 over the time it takes the second pump. This is a rational equation, and we can solve it the same way we solve other rational equations. Namely, we can clear fractions. If we wanted to, we could actually add those numbers together first, 1/4 plus 1/3, or we could just jump straight to the clearing fractions part. And to clear fractions, we just multiply all sides, or multiply both sides, because they're all 2 sides, by the common denominator. When you're finding the common denominator, don't forget about your variable. The common denominator is not just 12, which is what 4 and 3 fit into, but 12t. So if I multiply both sides by 12t, actually let me erase that. On the left-hand side, the t and the t simplify, and we're left with 12 times 1, or just 12. And on the right-hand side, this 12t gets distributed to both of those terms. 12 over 4 simplifies out to 3. We're left with 3t. And 12 times 1/3, the 12 and the 3 simplify out, and we're left with 4. So 4t. Now we have a linear equation, and we know how to solve that. 12 equals 7t. Divide both sides by 7. 12/7 equals t. So we could say that the entire basement would be drained in 12/7 hours. Or if we wanted to write that as a decimal, that decimal is 1.714285. But of course it's not that accurate. I don't have that accurate of numbers. What we want to do is look at the significant figures. So 4.0 hours and 3.0 hours means my answer should be significant to just 2 places. So that's going to have 2 significant figures of 1.7 hours. So these work problems, because that's what this is, when one job and another job, and we can even add in a third job, follow the general form of 1 over a plus 1 over b equals 1 over the total time, where a and b are the time it takes individuals to do the job, and t is the time it takes them to do the job together. If we had a third element in here, this would look like 1 over a plus 1 over b plus a third hose or pump draining the basement would be 1 over c. And that still adds together to equal 1 over the total time.